Good morning. This is a presentation for CDA-Cubesat Transponder. My name is Fernando, and I'm an engineer in the research center in the Mauá Institute. Now we will explain about our project, and I will share to you my dashboard. Well, this is a real picture of the CDA Cubesat that we create. For this project, we have some boards, and you can see it's easy to communicate between boards because we have two network CAN 0 and 1. 0 is for broadcast message, for message between one board or others, and CAN 1 is for emergency or critical messages, okay, for redundancy too. The power control board is the special board because this board control the power and make a redundancy between power supply. Okay. Reaction wheel boards control 3 reaction wheels in 3 axles. Radio board is a special board because we have 2 frequencies of communications, 400 for Argus communications and 144 for communications between the Cubesat and the Mauá station radio. Okay. Another board that we construct is quad-core DPU. DPU is a 4-arm M4 that we have implemented the same software in each microcontroller. This is a paper that we will present in France in the last year, me and Dr. Vanderlei Parro, that we create a software that make a votation codes in radiation's behavior. Then if you have received energy particle in the space, and we can make a mistake in some algorithms or not. And this algorithm rotate between 3 microcontrollers and decide if anyone is correct or not. Then we can make some particular corrections and erase this error. Okay. Application board is a board that is for communication to lab, because we have to test, and then the application board is not for fly. But in this case, our application board we will fly because this application board has a Raspberry board that creates a data log between GPU core and other boards that we can receive Argus communications, turtle or walrus or tsunami sensors in the earth. Then you have, if you have our planet here and Cubesat in a polar orbit, we can receive any sensors and create a log inside of Cubesat. Then when Cubesat flew over Mauá station radio, the Cubesat send every sensor received in these orbits. Okay. Well, This is our boards we have. First of all, we have the radio board that receive data in 144 megahertz. A power control board that we can control the power supply. Okay. Application board is the third board. We can see green is the Raspberry CN3. It's not a Raspberry, a common Raspberry is a slot like a memory in your computer. A quad-core DPU is the special board that I told you. Let me show you. This is a quad-core. We put this board in a balloon, atmospherical balloon, and you can see this picture is a GoPro. We send the balloon to 34 kilometers, and this board fail because we don't put this shield, and we want to see the problem. Then we can correct by code's algorithm. Well, this is the power board. We have measure of each voltage and current. Then we can distribute by a simple transistor. If one board fail or have biggest power consumption, okay, we can manage the battery. Well, this is a work that we do together, three students of Saint Etienne, a university in France. This is an assembly that we can see three magnetic torques for three axles and three reaction wheels, small reaction wheels, okay, to make a tooth control of this CubeSat. This base is a small friction, not zero friction. A small frictions only to permit me execute any situations or small tests in my table. Okay. Well, our students implementing LabVIEW, simple LabVIEW software to implement a PDI controller for reaction wheel. This reaction wheel is a BLDC control brushless DC motors. Okay, it's a good student project. Well, this is the application board. We can put here Raspberry in green, okay, and in a USB connector we have receive is a dongle is particularly is for high frequency, okay, SDR dongle, and it's simple because we can put Linux in a Raspberry, and the drive is a commercial drive for the dongle, and this is easy to create a simple data logger, for example. Well, this is a other radio board. This radio board is a particular schematic because we have a DTMF, like a telephone, a old telephone. You can press the keys and listen 2 tons DTMF, and this board send message to our base station via 144 megahertz uh, with modulation in DTMF. Okay. Well, for constructions, we do a project in a SolidWorks and put this project in a ANSYS for vibration and nodal analysis, structural analysis. Okay, and in the last year we have other mechanical graduation group that make your or final graduation project in antennas. We can see in the left picture, bottom left, the we have we have 4 coils, but when the thermal filament rupt, we can see 2 poles of antennas straight. Okay, one antenna for 400 megahertz, or another for 144 megahertz. Well, um, conclusions. Small platform could be constructed by students with reasonable cost and schedule. We work in this project for 4 years, and since 40 20 2040. Okay, and in the Mauá Institute of Technology, the CDA Cubesat in particular have begun to inspire a whole new generation of students interested in space science, technology, and missions. This is great because we can see students watching our job and want to collaborate and understand and make some question. And we have students enter every day in this room to make any project with us. It is good for us. Um, Finally, this leads us to think that we are on the right path to foster technology and acknowledgement for teachers and students and for our country too. Okay, and we have a small video. Let me see. This is our CubeSat, and not this. Sorry for my presentations. That's it. Thank you for watching these videos and see you. Bye bye.